we notice that sin t cos t is sin 2t, hence we categorized as an odd function, right? But how about, say, sin square of t? How about sin cube of t? What if we do not remember the trigonometric identities to reduce them into simpler forms, right? How about t, where it's just a function of time? How about t square, right? How about t square sin cube of t? In this part, we'll learn to identify whether these functions are even or not. The way we are going to do that is by looking at what are the properties that these functions satisfy. Specifically, we look at properties under multiplication. First thing we noticed, even function is when f of minus x is plus f of x. So there is symmetry about y-axis. Almost the function looks like mirror images about y-axis. Example is cos t. Odd functions are f of x is minus f of x, right? There is rotational symmetry about the origin, right? Rotate a function by 180 degrees, you get back the function. For example, sin t, okay? Now, notice the sign here will determine how products of two even functions or odd function and even function will end up. For example, let's take two even functions, okay? Very informally, when there are two positive signs, okay? So f of x and g of x both with positive signs, we will end up with the product being another even function. Even times even is even. It's like plus times plus is plus. The other hand, an odd function multiplied by an even function, we get an odd function. This is like minus into plus is minus. And of course, interestingly, when you take two minuses, that's two odd functions, multiply them, we get an even function. Okay? These are some simple properties of even functions under multiplication. Now let's use this in order to identify whether these are odd or even, okay? Where we don't need to know any additional formula in order to classify them. So let's take our original example, sin t cos t. Sin t is odd, cos t is even. So what is the product of odd and even? Okay, in this case the product is odd, okay? Whether it's odd times even or even times odd, doesn't matter, right? Okay, how about sin square t? This function is essentially two odd functions, sin t times sin t, okay? So this is odd, so the product of two odd functions, so this is an even function. How about sin cube of t? Sin cube of t, okay? That's pretty simple. We already know what sin square of t is. Sin square of t times sin t. What is sin square of t? This is even, this is odd, so this product is odd. How about just a straight line, go passing through the origin, okay? This is based on visually, we know straight line is an odd function. T square, it's a parabola, okay? T is this, it's an odd function. T square is a parabola, okay? It's symmetric about this, so it's an even function. Now, how about t square sin cube t? T square, just know it's even. Sin cube t, we know is odd. So how about this product? This product is going to be an odd function. So we know t square sin cube t is odd. Okay, and here is some exercise for you to practice and try it out. How about sin power 43t cos power 42t? Is this function even or odd? And at this stage, you might ask another question, right? You notice what are the properties of these functions under multiplication. How about addition and subtraction? How about Sine power 43t plus cos power 42t. Can we again use properties of even and odd functions under addition and subtraction to find whether this is even or odd? Yes, we could. I suggest you also try it out, and good luck. I'll see you with another video.